BLOWDOWN, Engineering Manager. BP, the barrier I own is plant design. Design codes take us through two main types of thinking. The first type of thinking is inherently safer design thinking, and the second is more into considerations of engineered systems. So engineering would start with the inherently safer design thinking, which is really all about removing sources of harm at source. So a simple way to sort of convey the point is the easiest way to remove a hazard is to not have the equipment that is associated with that hazard. So removing unnecessary equipment from a design is a key part in a safe facility. Location of equipment as well is an important facet in a safe design. That's why you typically see in an offshore facility the accommodation block located downwind and as far as practicable from the sources of harm, that is the oil and gas plant. Finally, there are also ways that we can over-design equipment to make sure that they are stronger than the stresses that they would be expected to see. In that way, we don't have to rely on secondary systems such as shutdown systems and protective systems to keep them safe. The considerations of engineering systems is more about detailing the systems that are there to protect, such as relief and blowdown systems and shutdown systems. So the basic architecture of codes covers the breadth of inherently safer design thinking and considerations of engineered systems. Design life is defined as the period of time which a piece of equipment or a facility is expected to last under typical service conditions and uses. So an example would be the legs of a platform. If they're expected to last 25 years, it means that they're expected to survive against the storms and the seas and everything that nature can throw at it for a period of 25 years. But what we typically find with the advancement of engineering is that the original designers were much more conservative than is currently understood. And so we typically find that older facilities can last for a period of time much longer than that which the original designers thought. The foundation is a good plant that's well maintained. So we start with the safe design. And then for the next period of a platform's life, it's about maintaining its condition. So the key points in that are to know where you are with respect to integrity management and being really honest about it. What we should be doing when we're trying to obtain replacement parts, say some period of time into a facility's life where the documentation may be obsolete or the parts are no longer easy to obtain. The first point in that is not to take a chance. It's important to check with the engineering support team about the parts that are being selected. There is no part on a facility that can't be engineered to have replacement parts. Offshore workers are arguably the most important barrier in a safe facility. They're the eyes and ears who move in and out of the equipment that keeps them safe day in and day out. It's important when they're doing that they are looking for and listening for changes to the equipment that may indicate that the equipment is becoming unsafe, and then to report it. And once it's reported, we will take action on that equipment.